Okay, in this topic we will be dividing a monomial by a monomial. Okay, so first thing we need to do to remember in this topic is to recall that to simplify a fraction we write both its numerator and denominator as the product of several factors and then divide out all common factors. What does that mean? Okay, it means this. Let me give you an example. Consider that you have 4 over 6. We can break this down, and this can be seen, well, 4 can be 2 times 2, and 6 could be 2 times 3. Factors 4 and 6. Okay, so these are the factors of 4 and 6 respectively, and then divide out the common factor of 2. So both of them have a common factor of 2, so we divide out the common factor of 2, cancel out, and then we are left with 1 times 2, 1 times 3, and that gives us 2 over 3. That's all. So let me write the notes here. Factor 4 and 6. Divide, which we did. Okay, divide out the common factor of 2. Not necessarily it has to be 2, it can be any other number, alright, as we will see in a little while. Okay, so let's go to our next example. The next example there. Consider that I have 20 over 25. Let's get the factors of 20. Factor 20 and 25. Well, 20 can be given as 4 times 5, and 25 could be as 5 times 5. You can go and break down 4 to smaller values like 2 times 2 if you want to. Okay, but since you have factored out at this point, you can stop right there and don't worry about carrying this down because you see something common here already. So the next step, cancel out. So I will just put this step here a little bit so you see how it gets cancelled. I'm just rewriting it over so you can see the steps. Cancel out, and then the next step would then be 4 over 5. I had skipped this step here and I joined this step and the first step in the first example, and we know with 4 over 5, and that is all that we are doing there. Okay, we can use the same method to simplify algebraic fractions that contain variables now. What does that mean? Well, we are going to divide now a monomial by a monomial, in other words. So let's put it now to use to what we are doing. Say for example, I give you 3p squared over 6p. Okay, let's get the factors of p squared and 6. All right, so the factor p squared and 6, we end up at the top to be 3 times p times p. That's the top piece, and the bottom will be 2 times 3 times p. We broke it down. So we have factor p squared and 6. Notice that p squared says to the second power, so therefore I put p times p. If this had said p to the third power, I would have put p times p times p. Okay, the next step, I'm going to rewrite the same thing from the top and show the cancellation. 3p p, 2 times 3 times p. In your case, when you're working this out, you don't need to write over. You could cancel out at the top. But I'm just showing you this was what I did first of all, and then I could cancel out. All right. So cancel out a p's, p cancel out, a 3 and 3 cancel out. All right. So divide out the common factors. So we write it here. What I did here, I divide out the common factors of 3 and p. Okay, that's what I did there. I divide it out. So now I end up with the next step as to say 1 times p times 1, that gives me simply p over, and I put here 2 times 1 times 1, that's simply 2. Or some people may want to write slash p over 2, which is more correct and precise, because remember all of these are small p's. So the only reason I would accept this is that there's no more p's there, and you may not want this to drop on top of this and cause a confusion. I would accept this. But if there had a capital P and a small p, then you need to differentiate it by putting the capital P on top of the line and the small p junction with the small line. Okay, so to divide monomials, we can use either the preceding method for simplifying arithmetic fractions or the rules for exponents. Okay, what does that mean? Let's see. Let's do some examples. So an example here is as follows. If I tell you divide x squared y over xy squared. Now notice we don't have no coefficients in front except the value of 1. So do we have a strategy to work this out? Yes. We'll use the rules for simplifying fractions and or the quotient rule for exponents. Okay, and I say and or because depending if we have division or whatever. Why? Well, because we need to make sure that the numerator and denominator have something in common, so or have no common factors other than 1. If that is the case, then the fraction is in its simplest form, meaning then they cannot be broken down any further. Okay, so let's see. Let's expand this. So this would be, well, x squared means x squared, so we put x times y over, and the bottom one is x times y times y. Okay, so that's what we end up with the bottom piece. So let me write this a little bit darker. So there it is, there it is. Okay, so we have just by simplifying the fraction, so we have made the fraction much simpler. So let's do this step here a little bit more, and then we're going to do cancellation. Now remember, you don't have to write a step like this again. You could have canceled right away, but I'm just showing you just in case if you join the video late or whatever the situation, you didn't get to see this one here. You get to see that after you have simplified, then you could start to cancel. So we cancel an x here, we cancel a y here. So therefore our result will be x on top and y at the bottom, and that's our solution. This is by simplifying fractions. The rules for exponent now is as follows. So this is by, we put it here, I'm going to draw a line here. This is by simplifying fractions. That's what that's the method. So we simplify the fractions and then we carry out and we got x over y. Let's use the other method. So I'm going to put the other method right beside it so we can compare, and then you will decide which method to use. Unless you are told what method to use, then you will, then yes, you do need to use that. So let's use now the rules for exponent. So we have x squared, I'm going to use it in blue, y xy squared. According to the rules of exponent, it says that if we have the same coefficient being divided and they have two different powers, we subtract the denominator power from the numerator power of the same coefficient. So therefore, this is the rule that we are using here. A to the power divided by a to the next power, a m minus n. That's the rule. So we take here x squared divided by x to the first, we put x squared divided by x to the first, we subtract 1, then y to the first at the top minus y to the second at the bottom. Okay, that gives us now x to the first, y to a negative 1. But recall that a base to a negative power, it is also equal to 1 over that base to the positive power. So therefore this is actually x over y, and we end up with the same solution. So this is using rules for exponents. So let's compare both of them, right? Again, you will decide what method to use depending, unless you are told to use that specific method, then you must use. So this method here is by simplifying the fraction. This method here is by using the rules of for exponents to solve for the fraction. So you're actually dividing. There's a quotient. All right. So it's not that difficult, just that you need to remember the rules. Okay. So let's do a next example. We're going to do it both methods, simplifying fraction and rules of exponents. Okay, you will decide which method to use depending on the problem. If they tell you to use a particular method, then that method must be used. Okay, there's no if and buts there. So consider that you've been given, was that here or example? Okay, that was just example. Consider that you have been given negative 8a cube b over 4ab cube. We need to expand that out so as to simplify it. So it becomes, well, 8 is actually negative 2 times 4, and a to the third means a times a times a times b over, the next one will then be, well, we can leave 4 as it is because we already have that 4 could cancel out, and then we have times a times b times b times b. Okay, so that's our step. So let me rewrite this over so we could do our cancellation. Again, you don't have to write it over like this, but you could start to cancel out. I am only writing it over so you see that the first step I need to do is to expand out, and then you cancel out. All right, so we're going to cancel right now. So now let's look at what we could cancel. Well, this 4 could cancel with this 4 because they're both divisible. A could cancel with this A. This B could cancel with this B. It doesn't make any difference. You could cancel with one of the bottom B's. So now you have here B here and a B here. Okay, so at the top we are left now equals negative 2 times A. Well, that gives us negative 2A squared over B times B, that's B squared, and that's our solution for it. Okay, now let's use the rules of exponent. Now this is by simplification. We'll use the rules of exponent on this side. So we have here negative 8 over a cube b 4ab cube, giving us, well, the 8 could be written as negative 2 to the third over and 4 2 to the second. Okay, the a still remains as a cube and b remains as b cube. Recall the laws of indices that says we subtract out the power, so we end up with negative 2 3 minus 2. This 3 minus this top 2 here. Okay, let me expand on that one there so it's much more concentrating on that particular problem only. Okay, so we end up now a cube minus the power 1 here, and then b at the top, which is the power 1 minus the 3. This gives us negative 2 to the first, a to the second, b to the negative 2. Okay, so this simply means that this is negative 2. We end up with negative 2a squared over b squared. So this is by exponent. Okay, so let's look at it carefully. We'll zoom in a little bit. We took the 8 and broke it down to a base, and we kept the variables. Then the 4, likewise, we broke it down to a base, and then we applied the laws of indices or exponents. So this is by, one method is by rules of exponents for exponents, and this is simplifying, to write it down, simplifying fractions. So both methods are welcome, but just remember, if you're told to solve it this method, then it must be this method. If I tell you to solve it this method, then it must be this method. You cannot decide to do a particular method if you're not told to use that particular method. All right, but whatever works, it works. Okay, so it depends on what you've been given. So, and let me give you a next example. Consider that I tell you now, simplify 25 open bracket r s t cube close bracket squared over 15 bracket s t cube close bracket cube. And I ask you also, and write the result using positive exponents only. So that means that if you are to solve this and you give me it with a negative power, it's not fully correct. It is incomplete because I want it in positive exponent. So that means you need to recall the laws of indices. So let's start working with this one here. Okay, let's see how we're gonna tackle this one. Zoom in a little bit more, this one here, and there it is. Okay, so we're only observing that one there now. So our strategy here is that we will use the rules for exponents to remove the parentheses. Then we simplify the fractions. So let me write that down. Our strategy: use the rules for exponents to remove the parentheses. Then we will simplify the fraction. Okay, that's the strategy. Use the rules for exponents to remove the parentheses, and then we will simplify the fraction. Why? Because we need to make sure that the numerator and denominator have no common factors other than 1. All right, if that is the case, then the fraction is in its simplest form if it has nothing more than common 1. So use the power for exponents. Okay, so we're gonna write out the first one, and we say now, so let me write out here. I put 25 r squared t cube squared over 15 st cube times cube. So the value here becomes now 25 r to the fourth, because 2 times 2, the rules of exponents, t, 3 times 2, 6, over 15 s to the third. Okay, let me just change this to an s, so it's much easier for us to work with something common. Okay, it should have been an s, so that's an s. So now I put here t to the ninth. So here what we have just done is this: use the power rules for exponents. And what's the rule? X, y to the n power, which could be any power, x to the n, y to the n, and x m n equals x m n. So if that was only one bs to a single power, then we use this, or we use this one here. Okay, so let's expand them out. So we end up with 25 is actually 5 times 5, and then we'll have 15 3 times 5. If you notice now, we'll apply the laws of exponent. This gives us s to the fourth minus 3, and then t will be t to the 6 minus 9. What have I just done there? Well, let me write it out here in red. Factor 25 and 15. We did that. If you notice, 5 times 5 and 5 times 3. Then use the quotient rule for exponents. Okay, and so we have x to the m over x to the n give us x m minus n. So that's the rule that we are applying there. So now I will rewrite this same step here over again, and then we're gonna see what then happens. So let me go down there and I put 5 times 5 times s to the first t to the negative 3 over 3 times 5, because that could have worked out. 4 minus 3, 1. 6 minus 9, negative 3. So now we cancel out these ones here, one of the 5s. And what did I do here? I divide out the common factors of 5. Perform the subtraction. So we perform the subtraction. Because we cancel out, we end up with 5 is t negative third over 3. But that's not our solution, because we were told to use the negative integers cannot be exposed, so we need to have it as positive. So we need to recall that if we have a base to a negative power, that becomes 1 over a to the positive m, or in this case it was t to the negative 3, that becomes 1 over t to the third. So our final solution for this would then be 5s over 3t cubed, and that's our solution for that one there. Okay, now this is how we go and work with these problems, and this is simply divide a monomial by a monomial. Okay.